Hey Apes, this is Mrs. Hubbard. I'm going to talk to you about Chapter 14. This is pollution is a big part of the AP test. 25% is about waste management and pollution, so I want to make sure we really go over Chapter 14 and all the other pollution chapters a lot. So if you look at page 381 on the Chesapeake Bay, you'll see that this area has been really messed with by people. A lot of um, the watershed has phosphorus and nitrogen coming into it from wastewater treatment plants like we went to on our field trip, and phosphorus and nitrogen also from manure and over fertilization of people's lawns and gardens and agriculture. So this area has really been over um, has overabundance of fertilizer, nitrogen, phosphorus. So because of that, they that allows a lot of algae to bloom. And when you have these algae blooms, then it sucks up all the oxygen in the water. The algae does, and then there's no oxygen for the fish, so the fish die off. So anytime you have an overabundance of nitrogen and phosphorus, you're going to have die-offs of fish, and that's what's happening in Chesapeake Bay. There's also problems with sediments. So sediments are the little tiny particles of soil that get carried down in the water, and they're having trouble with that in this area. They say 8.2 billion kilograms, which is 18.7 billion pounds of sediments come into the bay each year, and this messes with the gills of fish and all of those filter feeders that are in the ecosystem, like clams and oysters and things like that. It ruins their bodies and they cannot live. And then you have the base of the food chains messed up, so you're not going to have animals able to eat those base of the food chain, and then you're going to have those dying off, so you're going to have fish dying off, and higher animals, the eagles and things like that dying off. There's also a problem in this area because of anthropogenic chemicals. Anthro comes from is the word for man, so a lot of pesticides are coming into the watershed, as well as from humans. There's a lot of pharmaceuticals that are going through their bodies and going through the wastewater treatment plant and getting out into the water, and that's making some fish and other animals change their sex. So you're going to have hermaphroditic um, animals because they're ingesting hormones that humans are taking. So messing up with the reproduction of animals in the watershed. So look through that section, and let's talk about water pollution. Water pollution is defined as the contamination of streams, rivers, lakes, oceans, or groundwater with substances that humans make, and it negatively affects organisms. You have two ways those get into the ecosystem: by point sources. That just means like a pipe that lets out pollution, or non-point sources, which we see sometimes in the creek when we see oil sheens on the Marsh Creek. It's because people are washing their cars, or their engines are leaking oil. It gets onto the pavement, and then it gets washed into the storm drains by rainwater. So that's a non-point source. We're not sure where it's coming from. So over here's an example of a point source. And then you could have non-point sources. These animals, their manure could be washed into the creek. That's a non-point source. Human wastewater is all the things that we do that we can add bacteria to our water by washing our clothes, washing ourselves, using the toilet, all those things. That's human wastewater. In developing countries, they don't have the purification that we have in the United States. So people wash and bathe and go to the bathroom in the creeks and the rivers, and then it flows downstream to the next people, and they're doing the same thing in that creek, or that river, and so everybody's getting polluted. So a mark of civilization is if you have treatment for your wastewater. We're worried about wastewater because if you put poop in the water and it goes into the water, you have lots of nutrients, because when people or animals have stuff going through their bowels, there's still energy in that manure. So when that manure goes into the water, bacteria use it up, and because they're animals, they use oxygen as well, and then they deplete the water of oxygen, and then anything in the water any animal that needs oxygen and water are going to die off. So that's a problem with oxygen emitting waste. Also, our nutrients, like I said, are going to cause the water to be eutrophic, and that's a big word. You should know that word, eutrophic. You also should know what cultural eutrophism is. That means when people add nutrients to water, and then it becomes overstimulated, over-fertilized, and then lots of algae are there, and then it causes fish die-offs. And wastewater is a bad thing because it carries lots of disease organisms from our bowels and from animal bowels. BOD is the amount of oxygen that water needs, that water will use up as oxygen. It's the amount of oxygen that water will use over a period of time. So if you have water that has lots of nutrients in it, it's going to have a high BOD, and it's going to kill off all your fish and animals that live in there. Lower BOD is good, higher BOD is bad. Higher BOD means you have nutrients in the water, and the water's polluted, and it's going to need oxygen to break down those wastes. So remember, low BOD good, high BOD bad. Eutrophication is what I was saying. It means a lot of fertilizers in the water. Normally fertilizer is good, but in water it's bad because it makes all the algae bloom, and bacteria use a lot of oxygen to eat up all that fertility, all that nice energy, poop or manure or whatever's in the water that it's going to chew up on. It's going to need oxygen, so it's going to kill off fish and other things that need oxygen in the water. The other problem with allowing human wastewater to go into rivers and streams is because we have all these diseases that we can pass on to other people through water. So all of these diseases that you see on the screen have been around for millennia, and if we don't deal with our wastewater correctly, and wastewater from one person gets into the water, and the next person touches the water, then they're going to be able to get these diseases. And look, color is on the thing twice. I don't know why. Alright, so there's one way to deal with waste, and this is a simpler way, and it's just having each house or just small area having a septic tank. So what happens is the poopy water comes into the septic tank, the solids fall down to the bottom, and there's a bunch of bacteria in there chewing on everything, and the sludge stays at the bottom. The water that doesn't have so much bacteria in it anymore goes out into the leach field, and it percolates into the soil, and it's good for the grass because the grass gets nice and green because it has tons of nutrients. And over time, all that waste is broken down in they try to make they need to make the leach field long enough so that everything gets broken down. Over time, though, that septic tank's going to get filled up with sludge, and then you gotta clean that out. So that's the only problem with that one. You went to the sewage treatment plant. We've done a little demo on it, so you know that there's lots of different steps in a sewage treatment plant, and it allows large populations to get rid of all their waste. So there's lots of steps. So first step is all the water, the poopy water, is going to get to the water treatment plant, and usually water treatment plants are lower elevation so that all the water can flow to the waste treatment plant. Then they get rid of all the big stuff, the plastics and all the pieces of wood and bark and stuff like that, and dirt that got in there. So they're going to do that in step 2, get rid of that stuff with a filtering system. Then they're going to allow the solid waste sludge to settle at the bottom. all the bacteria and any big pieces of junk go to the bottom, and that sludge, they get rid of the water from it, and then they dump it in trucks, and then they truck it somewhere. Sometimes they use it as nice manure for land, or sometimes they just incinerate it, or they throw it in a landfill. And secondary treatment is where they're going to take bacteria are going to do the work to get rid of the rest of the organic material. And so you can have big giant pools and ponds of water with bacteria in there. You're going to put oxygen in there so that the bacteria can live. And then there's still bacteria in there because you have bacteria that have been chewing everything up. You got to kill those, and any other pathogens are in there that are bad. And so that's step number 7, where they're going to kill it with either chemicals like chlorine, or they're going to use UV light and or ozone and kill off the pathogens, and then they're going to release the water into the river or lake. So in the United States, our water is treated like this in municipalities. But sometimes when there's lots of stormwater, this whole system can overflow and go into the creek. So we do have times when in some poorly designed wastewater treatment plants, this stuff will overflow and go into the creek. And it's allowed to do that. They don't get in trouble for it. But that's not a good thing. Alright, so when you have lots of animals in one location, you're going to have manure lagoons. And you might have seen this when you go up Highway 5. You'll see the places where they have cows for milking cows and stuff like that. And there's big giant piles of manure that they put tarps over, and they put tires on top of the tarp so that it doesn't get blown all over the place. And they also have it they'll put it in big lagoons like this, where they have the pee and poop from the animals in here plus some water, and they'll just let it sit there, and hopefully it's going to get broken down. The problem with this is if you have a whole bunch of rainwater, it can overflow the banks and go into the local creek. Or if you don't line this whole pond with some kind of plastic liner or cement liner, then it can leach into the groundwater. And then if you have a drinking water well in that area, then the bacteria from the manure is going to go into your drinking water, which is bad. There's other things that can threaten human health, which is in water, which are these chemicals that you see here. Lead is bad for young kids, babies. It ruins their nervous system and their brains, and they can't learn very well. So it's going to mess with their learning. Arsenic is something that's naturally occurring in the groundwater, and sometimes it does get leached into our drinking water. So we have to be careful that we don't have too much arsenic in our water. It's a carcinogen, will give you cancer. Mercury also messes with your nervous system. And the way mercury gets into the water is that it's part of fossil fuels, especially coal. And when those things are burned, and if they're not, the gas emissions aren't treated correctly, then that mercury is going to go into the local waterways and pollute those waterways. So if you look on page 390, you're going to see that Asia is 54% of the world mercury production, and you know that Asia does not have the environmental laws that we have in the United States. So all that mercury is, a lot of that mercury is getting into the atmosphere and into the local waterways, which is bad for their people. Acids come from any time when you're burning fossil fuels or any kind of fuels that have sulfur in them or nitrogen. They make sulfur dioxide, and that goes up into the air, or nitrogen dioxide, it goes into the air. As soon as water hits it, it turns into either sulfuric acid or nitric acid, and this is bad for local waterways because we want the pH to be around 7 for the fish. But if you have acid in it, it's going to go low. So I told you a story about when I went to Canada and I went canoeing over this lake. It was totally a dead lake. And a lake next door to it, like a mile away, was beautiful. It had tons of fish. It had frogs. It had lily pads and everything. It was gorgeous. And the difference between those two lakes was like night and day. The first lake was totally dead. The second lake was full of life. And what I found out was that there was a local smeltering plant. I guess they were smeltering metals, and the acids would get into the air and deposit into that lake, and it killed the whole lake. It was a huge lake that got killed. So that's how acid rain can really hurt a lake. Also, you can get acid deposition from metal mines. So we talked about how they take mines and they like strip off top of the mountain. And when the water hits the ore, the rocks that are underneath the soil, they can turn water acid. So that acid water is going to leach down into the watershed and go into the creeks and lakes around there. So that's another way acid can get into our waterways. And then nowadays, lots of people are taking pharmaceuticals and hormones, and it goes out of our pee and goes into the wastewater treatment plant, and it's making animals change from male to female or female to male. It's doing crazy things with the reproduction of those animals. So we have to think about that in the future because we're really messing up the frogs around the world with this stuff. And we also have to make sure that we're not putting tons of pesticides in there. And this is all coming from agriculture and from what we use in our homes as well. So these are things we need to think about and try not to put them into our waterways. Here's arsenic concentration. So you see that in our area we have like medium amounts of arsenic. So we need to be careful that we don't have too much arsenic in our waters. It's not good for our bodies. This is what I was talking about with Asia. 54% of mercury is made in Asia, and I'm sure they're not in Africa as well. So this big 3/4 of our mercury in our world is being produced in these areas that do not have good environmental laws. So I'm sure it's getting to all the people there and hurting them. This is an example of acid mine drainage, and look at the color here. It's not a good color. This is not a healthy creek. I went up to the Sierras one time and I saw little what would you call it, pipeways, open pipeways that I could see that were full of bright greenish blue water, and it was unnatural color, and I knew that that was copper. So this is happening all over the world all the time. People aren't taking care to make sure that the mines that they make aren't allowing stuff to get in, acids to get into the creeks. If you look at this chart, which chemical do you see the most often in our wastewater from wastewater treatment plants? It's steroids, non-prescription drugs. We've got all kinds of stuff coming into the water from our waste, from our pee, getting mostly from our pee, some from our poop, but mostly from our pee. But anyway, it's getting in the waterway, and it's not good. Oil pollution happens naturally and because of us. So they mentioned that Exxon Valdez oil spill that was in Alaska, and it spilled millions of liters of crude oil. Also, they talk about the BP explosion in the Gulf of Mexico. So read about those. Those are very, very important, and I could see that AP would ask a question about that. So if we look at North American marine waters, look, the majority of oil pollution is naturally occurring. So under the ocean, there's going to be small leaks out of natural leaks that occur at the base of the ocean, and then that oil gets into the ocean. The ocean's used to that. The ecosystem's used to that. This is where we're having troubles with pollution. Is when we consume petroleum, some petroleum is going to get out into the waters. In the world, consumption's bigger, and transportation, they have more problems with leaks and spills in transportation. So North American versus worldwide, we're more natural than these guys are. So here's the problem with oil spills. Obviously, is going to kill and hurt all the animals that are there. The only way to take care of these animals is to physically clean them off, which is a hard thing to do, to get all the poor little animals cleaned off again. So what happens when they have an oil spill? They're going to take oil obviously floats on top of water, so they're going to take these things called booms, which are like floating little pillows of special chemicals that kind of absorb the oil, and they kind of lasso the oil on top of the ocean, and they try to keep it in one area, and then they suck it off the top of the ocean. So that's the way they deal with oil spills. And they can also, the second thing they can do is they can apply chemicals to the oil, and it allows the oil to break up and be dispersed inside all of the ocean water instead of sitting on top. And that allows the oil not to hit the shoreline. But the problem with that is we're not sure about the chemicals we're using to disperse all that oil. We're not sure how environmentally safe that is. So there's two ways to deal with spills. One, to do the booms that corral the oil and suck up the oil. And the second is to add chemicals to the oil and let it disperse the oil into the ocean before it hits the shoreline. So it's going to be all agitated and dispersed, not in one area, but kind of make it separate from each other. So less concentrated, so it's better for the plants and animals. So here's the two I was talking about. Oh, and the third one is they can add bacteria. Now they're trying to engineer bacteria that are going to be able to consume up the oil, eat it up, which is a great thing. That might be a really good way to do this. We also have other water pollutants. Out in the Pacific Ocean, there's a huge section of plastic garbage that's just floating up there. I think it's the size of Texas or something like that. Crazy big. We also have trouble with sediments because we mess with the way nature takes care of our water. Maybe like by construction, like we do mining, or we scrape away soil to make a new subdivision in a housing area. And when we do that, there's no plants covering up the soil and holding up the soil, so the rainwater just picks up soil and dumps it into creeks, and then plants and animals can't live with all that sediment. We also have thermal pollution, which hopefully we'll do a lab in class, where lots of times when you have energy production, you have waste heat, and that waste heat is they use water to hold onto heat in energy generation plants, in electrical plants, and all those kind of things. And so that water can be, if it's not treated right, can be dumped into lakes and rivers, and then you kill off fish, because fish want a certain temperature, and they also need the right amount of oxygen. So if you have if you have really high temperatures of water, that water does not hold oxygen anymore. Also, we're worried about noise pollution, especially in the oceans, where whales are communicating over long distances with really long wavelengths of sound. And if you disrupt that by, like the Navy likes to do sonar testing and making big noises with their submarines and stuff like that, it can screw up the whales. So that's another kind of pollution. So I would not like to live here. These people are gathering particular types of plastic that they can recycle and make money. But I don't think this is the way to deal with waste. This is a problem. See all the sediment coming in from this. I'm not sure the location of this, but this happens a lot it's in Santa Ana, California. So you see all this sediment because people are doing construction over here. They're like ripping open the land, and the rainwater comes down, grabs the sediment, brings it down here. And what's going to happen with these poor fish right here? There's going to be a huge die-off of fish right here, and all the clams and shellfish that here that you would like to eat. I would not eat this stuff. This is full of dirt dirt carries chemicals, usually metals that you don't want to eat, so, and bacteria as well. So this is not a healthy ecosystem right there. They also talk about in the book that big parts of I think near New Orleans, where the water gets dumped into the ocean, there's huge die-offs there. Yes, New Orleans. You're going to have another situation just like this, and you have huge die-offs of fish all the time because of all this sediment that comes in. And thermal pollution, like from nuclear reactors, power plants, and this is in power plant in Iceland. So they're using the water. The people are enjoying it, but if this water gets dumped into a local creek or river, it's not going to be a good thing for the fish because they're not going to have enough oxygen. High heat water has very little oxygen in it. So water laws, you're going to have to know these for AP. So know the Clean Water Act. I think it was signed by Nixon. Supports protection and propagation of fish, shellfish, and wild and recreation in and on the water. First big major environmental law is huge. Started the whole environmental movement, and we needed it. I think this was caused by what happened is back east there was a big river that would catch on fire every year or every few years, and it was just crazy. And finally people said, hey, enough of this, we got to get this taken care of. So the whole environmental movement started in the 70s, and Earth Day happened every year. And anyway, a whole bunch of people decided, hey, this is uncool, we're going to take care of this. So the Clean Water Act came about. Another good law is the Safe Drinking Water Act that came about in '74, and it sets standards for like arsenic and lead and things like that should not be, there should be standards for those. So all of our water that we drink in cities has to meet these levels for these 77 elements or substances. These are MCLs, maximum contaminant levels for a bunch of different stuff. So you can have up to 10 ppb arsenic, and people argue about that, about what's a good thing for arsenic. But these are the things that they've set. These are the law sets the maximum amount you can have. So you can't have any Giardia or fecal coliform. This is the indicator species that they talk about in this chapter. This comes from people's guts, so we don't want to see this in our drinking water because that means that our water has been contaminated by wastewater, by poopy water. So we don't want our wastewater treatment plant to dump anything into our drinking water. So that's why this is 0. These are the reasons that we have impaired waterways. Streams and rivers from bacteria, habitat, screening of water habitat, and oxygen depletion, and we talked about that in this lecture. And this is where they come from. Agriculture is a big one. Changing the stream bed, like think of changing Marsh Creek and just moving it a mile over, and so changing the whole waterway by people, like bulldozing a new creek. That's what they're talking about, water diversions, and making dams. Lakes, ponds, and rivers, we have trouble with mercury, PCBs, and nutrients, too much nitrogen, too much phosphorus. And this happens by people burning things and it coming down in our rainwater, and by agriculture, too much fertilizer getting into our lakes, ponds, and reservoirs. And then our bays and estuaries, like where we live, bacteria, oxygen, and we can't eat too much fish out of our estuary because if you eat too much, you're going to get too much mercury, you get mercury poisoning. So that's happening because of people dumping stuff in, cities dumping things in, including our sewage, and also from atmospheric deposition, which means that people burn things or they cause dust to happen, and then it gets deposited into our bays and estuaries.